I am Emily Reese, and this is Artifact 11, demonstrating my ability to facilitate learning with technology. Within this artifact, I describe a creative computing project I developed and implemented in my third grade classroom. Working in collaborative groups, students chose and researched an animal in a Georgia habitat and wrote a report detailing the adaptations that their animal had that allowed it to thrive. This aligned with Gwinnett County Public Schools Science AKS 4C, construct an explanation using evidence of how external features and adaptations of animals allow them to survive in their habitat. Students used various classroom materials to design and create their animal. Students also created a make code that included one input and one output function. The MakeCode digital platform allowed students to utilize their interest in coding and collaborate with their peers, all while learning a new technology tool to bring their work to life. Students used laptops to access the MakeCode website where they had access to a student account. Students shared the microbit and other technology materials needed for their project. I created a Google Classroom module to combine project guidelines, expectations, and steps, as well as a platform for support requests, tutorials, student upload of designs, and feedback. The project guidelines, expectations, and steps included in the Google Classroom module provide evidence for Criterion 20, manage the use of technology for learning in a non-traditional classroom setting. The project guidelines and expectations were categorized into 3 sections: technology use, troubleshooting, and our safe space. Outlining and communicating clear guidelines at the onset of the project allowed me more flexibility in supporting student learning during work time, support their use of technology, and more importantly, allowed opportunities to give feedback on student progress and creative thinking. The computer and technology guidelines are based on the Gwinnett County Handbook information for students and families, as well as my established classroom expectations and procedures for using technology. This policy states that school-issued devices may only be used as directed by the teacher. As so, I included a list of approved digital platforms for students to access and use for this project. The project guidelines include resources for students to utilize for support and to troubleshoot their needs prior to reaching out to me. This included peer help, the aid of our STEM specials teacher, and access to the MakeCode help videos. Promoting collaboration and giving responsibility to students are ways in which creative skills can be nurtured within the classroom. Establishing and maintaining a safe space was critical to the design process. Students needed a trusting environment that promotes taking risks, experimenting, and making mistakes. I presented the Our Safe Space guidelines in the project to convey to students that encouragement and being supportive is key in how others collaborate and communicate with one another. The lesson plan and student work samples from my creative computing project provide evidence for Criterion 21, create opportunities for students to use a design process and/or computational thinking. I developed and implemented a project with my third grade students in which they used a design thinking process as well as elements of computational thinking to choose and research an animal in a Georgia habitat. Students then used various classroom materials to design, create, and code their animal using MakeCode and microbits. My animal adaptation pet robot lesson plan is organized by each step of the creative play learning spiral. I began the lesson by introducing the design thinking process and outlining the Google Classroom learning module students would be using to document their own design thinking processes. After introducing the design thinking process to my students, we started with an overview of the rubric for the project. The rubric created was vague, yet provided students with enough stability to understand the expectations of the project and the outcomes of their creations. After students had a clear understanding of the rubric, we moved on to the Imagine step. In this step, I presented to students the premise of the project, and students were encouraged to use pictures and words to document their ideas. These are examples of student groups in the Imagine step of the design process. Providing only a general description of the project was important in fostering student creativity and imagination. Even with sharing the rubric first, students were creative and collaborative with one another in this process. I then introduced students to computational thinking processes by modeling abstraction, decomposition, pattern recognition, and algorithms. Having students utilize the coding program MakeCode to create their robotic pets offered them an opportunity to use all components of computational thinking. Using decomposition, students broke down the requirements of the project by looking at the project rubric. Within student groups, they also broke down the steps needed to create their animal and which materials would work best. For pattern recognition, students use MakeCode to recognize patterns in the code in order for their robot to be effective. When researching animal adaptations, students also identified patterns in the different adaptations animals have, as well as identified patterns in the creation and construction of their robot animal. Using its abstraction, students were asked to create a report to showcase their research. Students were given a time constraint to complete this part of the project, which meant that students needed to quickly determine the most important information to include in the reports. And lastly, algorithms. The students had to create algorithms to have their code work as it should. Students were given choice in how they wanted to publish their animal research. They had the option between creating a poster, designing a Google slide presentation, or recording themselves via Flipgrid. The next step was the creation phase of the project. Students used materials found around the classroom and created their robot. Students also began to tinker with which microbit input and output they wanted their robot to perform as they designed their robots. Once students had created their animal, students were given time to play with their project. During this step of the creative learning spiral, students were encouraged to honor both their successes and failures. Students were given the opportunity to share their final project with the members of the White Oak STEM Club. STEM Club members came to our classroom, and students participated in a gallery walk of the different animal adaptation robots. The STEM Club members filled out a Glows and Grows feedback form for each group of students. The feedback provided helped my students to see ways to improve their designs and make it better. Due to time constraints, students did not have the opportunity to revise their designs based off of the feedback given by the STEM Club members. The teacher did discuss with students that in the creative learning spiral, there is sometimes another imagine process where the feedback is taken, the design is improved, and possibly retested again. The Animal Adaptation Pet Robot Creative Computing Project demonstrates my ability to create learning opportunities for my students that challenge them to use a design process and computational thinking to innovate and solve problems. Students' use of the creative learning spiral and elements of computational thinking is evident throughout the students' final work products. The creative computing project that I implemented in my third grade classroom provides evidence for Criterion 22, Model and Nurture Creativity. Working in collaborative groups, students chose and researched an animal in a Georgia habitat and wrote a report detailing the adaptations that their animal had that allowed it to thrive in the habitat. This aligned with Gwinnett County Public Schools Science AKS 4C. Students used MakeCode and microbits to include one input and one output function for their animal adaptation robotic pet. By creating their own MakeCode project and viewing other groups' projects, students were able to make important connections between the unit concepts. Throughout the school year, I had talked with my students about my own experiences as a learner in graduate school. I shared with my students that I am working towards a degree in instructional technology, and one of my assignments included teaching students a new technology tool I had learned. I told my class about the experiences I had and how those experiences taught me that anyone can be creative. I also explained that creativity requires effort. During the lesson, I shared with students 3 creations I had made in my class. I expressed vulnerability when sharing my work products with my students, including outlining my struggles and challenges, as well as requesting their feedback on my creations. I shared with students that as they progress through the project, they would be able to observe and provide feedback on how I am developing my creativity as their teacher. Working creatively involves taking risks, experimenting, and making mistakes. To nurture this creativity, I included a section in the project guidelines called Our Safe Space. I presented students with expectations that we encourage one another to try new things, and when we do make a mistake or struggle, we see it as a learning opportunity. Students were given the opportunity to share their final projects with the members of the White Oak STEM Club. My students demonstrated one at a time how their animals moved or lit up. Then both groups reviewed how to give feedback based on the Glow and Grow conversation sheet. The STEM Club members filled out a Glow and Grow feedback form for each group of students, and the feedback provided helped my students to see ways to improve their designs and make them better. Giving students autonomy in their work and creative expression is key when nurturing creative thinkers. I intentionally provided students with a limited project description and kept my rubric simple and vague so that students would develop as creative thinkers. A compassionate and accepting environment is key to developing students' creativity in the classroom. A crucial component of my role as an educator is to establish and maintain relationships with my students that focus on kindness and positivity. Because of these relationships, I was able to more effectively nurture creativity and creative expression as students engaged in the creative computing project.